Hello, good people. Welcome to video number 2 here of talking about the harmonic and P series. So this is a fairly straightforward situation where we're looking at infinite series that have this particular pattern. But in questions 3, 4, and 5, the problem has changed here. The question is not whether it converges. The question is, for what values of k would the series converge? Well, first, as we look at number 3, we recognize this is really a p series, right? This is a p series where it's 1 over n to the p. So my p-value is 2k minus 5. Well, if I want it to converge, well, then I need to set that p-value to be greater than 1. And if I do that, that means 2k has to be bigger than 6. And if I do that, that means k has to be greater than 3. Right? How do I know that? Because I took the exponent, it had to be greater than 1. I added 5 on both sides. I divided by 2 on both sides. So my k value has to be bigger than 3 in order for this infinite series to converge. And this is kind of getting a taste into where we're going, which is we're going to be looking for intervals of values that would make a specific series converge. Well, if we know what the rules are, then we can apply the rules and figure that out. For number 4, I notice we have 1 over n times n to the 2k. So wait, I have n to the first power times n to the 2k. So I can really rewrite this as from 1 to infinity, 1 over n to the 2k plus 1, right? Because this is n to the 1 times n to the 2k, so I'm adding the exponents and I get 2k plus 1. But that's my p. My p value is 2k plus 1. I need it to be greater than 1 in order to converge. And now I'm just going to solve for k. So I'm going to subtract both sides by 0. So I'll get this, divide both sides by 2. So k just needs to be bigger than 0 in order for me to have a sequence, an infinite series, I'm sorry, not a sequence, an infinite series that converges. Well, that's not too bad. We can do that. And then I get to number 5, and I notice number 5, I don't really have a p-series because I have n on top and I have n on the bottom. So what's up with that? Well, for number 5, what we're going to do is kind of play a little sleight of hand trick here. We're going to divide the numerator by n and the denominator by n. That means we're going to divide everything on the bottom by n. Now, why are we doing that? Whatever I do on the top, as long as I do it on the bottom, everything stays equivalent. But look what happens when I do that. In the numerator, I'm going to get a 1. Hey, that's kind of the start of what a p-series looks like. In the denominator, if I'm dividing powers of n, this is really n to the power of 4k minus 1. And then this, I can't really do much with it. This is just 5 over n. Now, as I go into infinity, this fraction is really going to depend on the first term. I'm sorry, this fraction, this function, or this series will really depend on this part, not this part, because as n goes to infinity, this will become so insignificant, it's going to go to 0. And then I'm really left with a p-series right here. And right here, the only way for that p-series to converge is for that exponent to be greater than 1. And if that's greater than 1, we add 1 on both sides to get 2. We divide by 4. So k has to be greater than 1/2 in order for this series to converge using the p-series test. That's where we're going in terms of trying to find ways to determine convergence and divergence of infinite series. So by now, we've talked about 3 specific series. In other words, I'm looking for a specific pattern, and if I recognize that pattern, then I know whether it's convergent or divergent. And then we also talked about to tests. Now, these tests can work with any type of series, right? These are specific types. These are specific patterns you're looking for. These are tests that we can perform on any infinite series and determine divergence for the nth term test or convergence and divergence for the integral test. This is what we're going to be focused on here in the next couple of days. I'm going to go ahead and pause the video there. I'm going to save the practice problems for class. So if you would, I'm going to ask you to do number 1. I'm going to ask you to do number 3. And I'm going to ask you to do number 6. If you can do 1, 3, and 6 and bring them to class, we can talk about those and how they work.